Okay, today's notes are going to be kind of a continuation of what we learned last time. We're going to be working some more with the fundamental theorem of calculus, and we're also going to learn a second fundamental theorem of calculus, or sometimes it's called part 2 of the fundamental theorem of calculus. And we're also going to be looking at average value in today's lesson. So we have quite a few new things to explore. Some note cards that you are going to need to add to your stack for today's lesson. I'm going to write them out here because we're going to be using them in our example problems. Let's say that the front of the note card will be on this side and the back of the note card will be over here. So last time we learned about the fundamental theorem of calculus, sometimes abbreviated FTC for short. And that's when you integrate from a to b f of x dx. And on the back of the note card, you're going to say that that equals capital F, which means the antiderivative of the function of the function f, I apologize, with the variable b plugged in, which will actually be a constant, whatever number is up here, minus the antiderivative of f of x with whatever number you have down here for a plugged in. So that's how you can calculate definite integrals, and that was the topic of discussion last time. So then we also have a new formula which is called the average value formula. And the average value formula is used to find the average value of a function. You know how averages, like your grade average, is found by adding up all the numbers and dividing by the number of numbers? Well, this formula can be used to find the average of any quantity that you have an equation for over time, like say average temperature or average distance or average cost, whatever you can write an equation for. And so it's going to be 1 over b minus a times the integral from a to b of f of x dx. So you integrate your function from whatever starting time to whatever ending time they give you. So it's like the average temperature from this month to that month. And so you'll enter those as your lower and upper limits of integration. But you multiply by a constant in the front of 1 over the difference of the upper one minus the lower one. So that's how that formula works. Next, we have the second fundamental theorem of calculus. Some textbooks don't call them the first and the second fundamental theorems. Some call them the fundamental theorem of calculus part A and part B, or part 1 and part 2. So depending on what textbook you look at, they might refer to this one in a different way. But basically, the fundamental theorem of calculus part 2, or the second fundamental theorem of calculus, says if I take the derivative of an integral, remember derivatives and integrals are inverse operations, from some a value, this is a constant, to x. So my ending value on the top is a variable, x, of f of t dt. The answer to that is just going to be f of x. So basically this variable on top drops into your function to become the independent variable, and that's it. You're done. We'll look at some examples so you can see how that plays out. There's also an extension of this one, the second fundamental theorem of calculus, with the chain rule. So that one is going to be where you have the derivative of an integral from some constant to a function on top of f of t dt. So the only thing that's changed from this one to this one is instead of just having the variable on top, this time we have a whole function up there. And so this one, you're still going to drop that function in as your independent variable, f of g of x. But you have the added step that you have to multiply by g prime of x. Okay, and the last one that I have for you today is one that I didn't used to include in my note card set. And I added it at the request of my students because there's a whole lot of problems that it seems to be very useful for. So I've called it the new y value note card. And it's to find f of b. And what goes on the back of that one is f of a plus the integral from a to b of f of x dx. Now, what this is, essentially, is another version of the fundamental theorem of calculus, where you add f of a to both sides of the equation to isolate f of b. And this is a very common way for them to ask you a problem. So you will find this to be very helpful in your assignment today. So we will now begin doing some example problems to practice using these different note cards that I've started you on today. So the first example I'm going to do with you is find the average value of f of x equals the cosine of x on the interval from 0 to pi over 2. So this is the average value note card. So this is my a value and this is my b value, and then I have my function f of x. So the way I do this is 1 over b minus a times the integral from 0 to pi over 2, from a to b, of the function f of x, cosine of x, dx. So 1 over pi over 2, if I divide by a fraction, I multiply by the reciprocal. So that would be equal to 2 over pi. And now I'm going to do the antiderivative of cosine, which would be sine, because the derivative of sine is cosine. And then this will be evaluated from 0 to pi over 2. So I'm going to leave my constant multiplier out here in the front till I finish with my definite integral. So I'm going to go plug in the upper number, sine of pi over 2, minus plug in the lower number, sine of 0. And of course, the sine of pi over 2 is 1 from our unit circle, minus the sine of 0 is 0. So this is just 1 in the parentheses. So the answer would be 2 over pi. Okay, next one, number 2. We are going to find the average value of f of x equals 1 over 2x. And we're going to have the interval from 1 to 4. So we're going to use that average value formula. This is my a, this is my b. 1 over b minus a times the integral from a to b of f of x dx. Now, in front, this is going to simplify to 1/3. This is not set up very nice for integration, my function. I could think of this as 1/2 times 1 over x, and then pull the 1/2 out in front and multiply it by the 1/3. 1/2 times 1/3 will give me 1/6 times the integral from 1 to 4 of 1 over x dx. 1 over x integrates as the natural log of x. That's one of your note cards. So it's going to be 1/6 times the natural log, technically of the absolute value of x, evaluated from 1 to 4. So we're going to sub in the upper number, subtract what we get when we sub in the lower number. 1/6 of the natural log of 4, and the absolute value of 4 is 4, so we don't need the bars anymore, minus the natural log of 1. And of course, we remember that the natural log of 1 from algebra 2 is equal to 0. So this is just 1/6 times the natural log of 4. All right. Next, we'll do number 3. Find the average value of f of x equals 4x squared plus 4 divided by x squared, and this is going to be on the interval from 1 to 3. So we're going to need to use that same formula, but do you see this function is not really set up very well for integrating? Let's think of how else we could write this. F of x we could write as two separate fractions, 4x squared over x squared plus 4 over x squared. Kind of like if I was going to take 5/7 and add it to 1/7, I could put those together by going 5 plus 1 over 7. Well, this is like the way I started, and I'm splitting it up into two separate fractions with that same common denominator. That's going to make it a little bit easier for me to integrate after I simplify this, because here the x squareds will divide out and I'll just be left with 4. And the other one I could write as 4x to the negative 2, so I could use the power rule backwards there. So I'm going to use the function in this form instead of the way they gave it to me. So this is going to be 1 over, this is a, this is b, so b minus a, 3 minus 1, times the integral from 1 to 3 of 4 plus 4x to the negative 2 dx. So we'll simplify out front. 1/2 times the, well, we could go ahead and integrate. The integral of 4 is 4x. And if I add 1 to my power, I get negative 1. Multiply by the reciprocal of my new power, negative 1 times 4 is going to be negative 4. And then this is evaluated from 1 to 3. So 1/2 times, we'll go ahead and sub in the upper number, 4 times 3 minus 4 times 3 to the negative 1, minus 4 times 1 minus 4 times 1 to the negative 1. Now we have some arithmetic to work on. 1/2 times 12, this will be minus 4/3. minus 4 minus 4, because 1 to the anything power is 1. So now I have 1/2 times, let's see, if I wanted to write 12 in thirds, it'd be 36 thirds, because 36 divided by 3 is 12. And then this is just minus 0 here. So 36 thirds minus 4 thirds is 32 thirds. And when I multiply that by 1/2, 32 divided by 2 is 16, so 16 thirds would be the answer. Okay, so we've gotten some practice with average value. Let's try some practice with our new second fundamental theorem of calculus. So for example 4, it's going to say, find the derivative of the integral from 1 to x of t cubed dt. Well, all you do is take this x, drop it in place of the t, and write that function as the answer. Now you might be going, but why, Mrs. Heiss? Why would you do that? Is it magic? No, it's not. It's math. Let's do it the long way, okay? If you were to take the derivative of this integral, well, let's integrate it. T cubed integrated, do power rule backwards. Add 1 to the power, multiply by the reciprocal of the new power, and then let's evaluate this from 1 to x. So we're going to sub in an x, 1/4 x to the 4th, and then we're going to subtract what we get when we sub in the 1, 1/4 times 1 to the 4th. Okay, so we're going to take the derivative of 1/4 x to the 4th minus 1/4. So now if I take the derivative of 1/4 x to the 4th, I bring the 4 down and multiply it by the 1/4, which gives me a coefficient of 1. And then I subtract 1 from my power using the power rule with derivatives. That'd be x cubed. And then the derivative of 1/4 or negative 1/4 is 0. The derivative of any constant is 0. So it really wouldn't have mattered if this was a 1 or any other number, because when you plug it in, you get a constant. And when you take the derivative of the constant, it goes away. So you just get x cubed. But you get it a lot faster just by sending that x in place of the t here and writing down the function. So let's try another one. How about the derivative of the integral from 0 to x of the square root of t squared plus 1 dt? What's that one going to equal? Throw the x in place of the t in the function. Square root of x squared plus 1. That's it. When you see the derivative in front of that integral, I need you to think second fundamental theorem of calculus. This one should be an easy one, okay? So the next one, derivative of the integral from 7 to x. Does it matter that this one was a 1 and this is a 0 and this is a 7? No, it doesn't matter at all. Of 2e to the t minus 3 sine t dt. Okay, this looks really complicated, but all we do is take this function, replace the t's with the x's, and that's it. The derivative and the integral undo each other. So 2e to the x minus 3 sine x is the answer. Are y'all liking the second fundamental theorem of calculus? My students usually do. I'm hoping you're in that group. Okay, number 7. Now we're going to throw a little curveball. Instead of having x on the top, we're going to put a function of x. I'm going to put x cubed up there. Okay, so it's kind of the same. you're going to take that x cubed and drop it in place of the t because the integral and the derivative undo each other. So it's going to be the cosine of x cubed. But then you have to multiply the whole thing by the derivative of the function that's on top. This is applying the chain rule, okay? So it's going to be 3x squared times that. And, I mean, we might write it with 3x squared in front, so we don't need parentheses to separate the argument of the cosine function with the 3x squared. But that's it. That's done now. So a little extra step, but not too bad. How about this one? Number 8. The derivative of the integral from 2 to x squared of 1 over t cubed dt. So we're going to take out the t, replace it with the x squared. 1 over x squared quantity cubed. Then we're going to multiply by the derivative of that function that's on top, which the derivative of x squared is 2x. So we have 2x on top and x to the 6th on bottom, because when you raise a power to a power, you multiply the powers. Let's simplify this. If you have an x on top of an x to the 6th, that simplifies down to x to the 5th on the bottom, and that is the answer. All right, I want you to try this one on your own. Pause your video, see if you can do it, and then play it again to see if you got it right. The derivative of the integral from 0 to x squared of the sine of t squared dt. All right, pause the video, give it a try. Did you get 2x sine of x to the 4th? If so, you did it right. Good job. All right, I just have one more example for you today. This one is a calculator problem, and you're going to be given that f of x is equal to the integral of the natural log of x over x squared dx. F of 1 equals -1. Find f of 4. So your directions are to use a calculator, and you are going to have some problems today where you're supposed to use a calculator to do the work. And you need to give your answer rounded to 3 decimal places. Hopefully you've got a good way to do graphing calculator work at home, whether that is an actual graphing calculator, or perhaps you've got the app on your Chromebook, TI-84 Plus Graphing Calculator app, or perhaps you have the free mobile phone. There's an iPhone. It's called Calculate 84, the app. It's a free app. Or you've got on Android phones the Wabbit Emu free app that does the same thing as this graphing calculator, but you're going to need a calculator for this. So email me if you're having calculator issues. But we're going to use the new y-value formula that I showed you, that is a special extension of the first fundamental theorem of calculus, or the fundamental theorem of calculus part 1. So the new y-value note card says that f of b equals f of a plus the integral from a to b of f of x dx. So whichever one they're wanting you to find is going to be the f of b. So we're going to say f of 4 equals, the one they give you is your f of a. So f of 1 plus the integral from, your a is this number of the given function value, So we'll put 1 down here. And your b is the value that you're trying to find the function evaluated at. So the 4 goes up here. And then f of x, capital F of x, is the integral of this f of x function. So natural log of x over x squared dx. Now this has to be a problem with the calculator because I haven't taught you how to integrate this by hand. So don't try to do it by hand. And on the AP exam, they may give you one that you don't know how to do by hand either. Okay, so you got to watch out for that. You know, we're working right now in Calculus 1. There's Calculus 2, Calculus 3, Calculus 4. There's more calculus to come. You haven't learned it all yet. So they'll throw stuff at you in the calculator portion sometimes that they know you don't know how to do by hand. So f of 4 is what we're trying to find. And we do know f of 1. They gave it to us. It's equal to -1. So -1 plus the integral from 1 to 4 of the natural log of x over x squared dx. Okay, so this is what we're going to type in the calculator to get the answer. And we'll round it off to 3 decimal places. So in your calculator, what you're going to press is the green alpha button and then the window button. And that's going to pull up this menu. Option 4 says FN int, which is standing for function integration. So we're going to choose that option 4. And look at what comes up on our screen, a nice little integral. Okay, so we're going to type in 1 on the bottom and then move up to the top to 4. Cursor over here to the right in the parentheses, and we're going to put our function. So I'm going to go alpha y equals number 1 for numerator over denominator. And then I'm going to put natural log of x in the parentheses. And we always say natural log, not ln. It's French. Log naturel. The order of the letters is because of the French. And then on the bottom, x squared. And then we're going to go outside and type the x because we're doing dx. Derivative with respect to x is what we're working on. Well, we're integrating with respect to the variable x here. So we got it all typed in just like we wrote on the paper. Oh, except for I forgot to put the -1 in front. Well, I can insert that if I scoot all the way to the front and go second and press the delete button, which is INS for insert, and then type -1 plus. Whoops, should have typed that first, but I got it in there. So we got it all entered now just the way we see it here. Press enter, -0.59, and then this third digit is a 6, but the number following it is 5, so it's going to round it up to a 7. -0.597. So all answers on the AP exam, if they are with a calculator, are supposed to be rounded to 3 decimal places unless you are explicitly told otherwise in the problem. And they do that. Sometimes they will say round to the nearest integer or something. It depends on what kind of problem you're doing. But most of the time you're assuming a 3 decimal place rounding for the answers on the calculator portion of the AP exam. So that one is done now. Now I'm going to give you a little warning. In your homework problems today, some of the problems are going to be real super easy, just like the little second fundamental theorem of calculus problems. You'll be able to zoom through those. But there's some in there that are actual AP problems that are extensions of what we've learned. They are going to ask you to apply learning, to think outside the box. This is done intentionally because on the AP exam, they're going to throw you some curveball problems. And I have to throw you some curveball problems throughout the year so that you feel prepared to handle those. If you struggle with some of them, it's okay. Okay, I'm going to also put the answer key to the work on Google Classroom for you. But feel free to call a friend. Feel free to ask me for help. You'll get it. Have a great day. Bye for now.